Hello kids, welcome to Radhika Smart Classes. Today we are going to learn ray diagrams of concave mirror and convex mirror. So concave mirror is called converging mirror, we learned yesterday. So concave mirror has total 6 ray diagrams. How many ray diagrams? 6 ray diagrams. So when we talk converging mirror, it has a 6 ray diagrams. It is very easy to remember, trust me. There is one trick I will teach, but before going to that, I will teach you how to draw principal axis and mirror with proper measurements and to get the perfect ray diagram. Let's start. So please take a sharp pencil, protractor and scale. So this is a scale I have got. Just draw full, you have a 15 centimeter scale, draw full one line. This is your principal axis, right? Now, what will I do here? I will take a protractor. So now understand, you have protractor. Rotate this protractor like this, right? Keep this protractor at like this so that your 90-degree should touch the principal axis. Your 90-degree should touch the principal axis. You have to adjust like this. Can you see, guys? My 90-degree protractor. Now you can draw the mirror 60 mark here and 60 here. You get the perfect diagram. This is your mirror. Just you have a pencil, draw the mirror. You can draw little bit thick mirror also. That's absolutely okay, right? So this is your mirror. Do the coating. I hope everybody is getting. This is M dash mirror. This is the pole. Now, again take the scale. Now, what should you do? Keep 6 centimeter here. Please keep 6 centimeter or you can take 8 centimeter also. Both are same. So keep 6 centimeter. 6 should come at the pole and 0. So mark 0, mark 3, right? Now this 0 represents the center of curvature. This represents the focus. So this is your skeleton for all the 6 ray diagrams. So I request you, please draw all 6 diagrams like this. Yes, remember one thing, like you have a notebook. This is your notebook. So draw the mirror at the 3/4 of the page. Please draw the mirror at the 3/4 of the page. So 1/4 should left behind, 3/4 should be in the front. Now, first ray diagram. Let's start. When the object at infinity. When the object is at infinity. When the, what is the position of the object? Object is at infinity. Means your object distance is very far. Your object is very, very far. Example, sun. Example, sun. Right, guys? Understood? So, when I talk about infinity, so how the rays come? Rays come parallel to the principal axis. We don't show any object, no need of object because object is very far, and second ray coming parallel. This is the first incident ray. Every incident ray has a reflected ray. Okay, I will draw the reflected ray with another color so that you can clearly see. First incident ray, how will it reflect? It will pass through the focus. This is the first reflected ray. This is the second incident ray. From here, second reflected ray will pass. This is a reflected ray 2, where both rays are meeting at focus. So what is the characteristic of the image? So what are the characteristic of image? Shall we write? NPS. Characteristic matlab means and nature, position and size. Nature means real and inverted. This image is real and inverted. This image can be caught on a screen. Position at focus. Size, point sized. point sized. Hope everybody understood. So this first ray diagram is done. Good job. Come to the second ray diagram. What is the position of object? First position was infinity. Second position is beyond C. Object is beyond C. Where is the object? Beyond C. Away from the C. Means your object distance is more than the radius of curvature. How we draw? Shall we draw, guys? I am just erasing my first ray diagram so that I can teach you the second ray diagram properly. This is the focus, right? So where is the object kept? This is C. Here is the object. Don't draw object too big. You have a ruled notebook. This is your ruled notebook. So one line object is enough. So this is my object AB. So first ray go parallel. First ray go parallel to the principal axis. How will it reflect? Everybody knows. It will pass through the focus. First reflected ray, right? Second, how will you draw? Second reflected incident ray pass from the C, center of curvature. So now rays going along the center of curvature, it will reflect along the center of curvature, right? Understood? So where the image is forming? Where the image is forming? Anyone? Image is forming between C and F and below the principal axis. It is below. This is my principal axis. Image is going below the principal axis. So what is the characteristics of the image? What is NPS? Nature is real and inverted. Real and inverted. Position between C and F. And size diminished. It is diminished means it is smaller than the object. Am I clear? Pakka? 100% sure? Don't change the measurement. Shall I move to third ray diagram? Come. Let's draw the third ray diagram. Object at C. Object at C. Now, object at C. What does it mean? Object distance is equal to the radius of curvature. Shall I start? I will again erase. Okay. Right? So, this is F, this is C. I will erase this A so that there is no confusion. Now, where is the object? Object is at C. Object is at C. How will it go? First ray will go parallel. What is the name of the object? AB. Right? It will strike the mirror. It will reflect through the focus. So if you will keep the scale, guys, this ray will absolutely come. It should directly, if you have a scale, you can pass direct. I'm sorry. It should directly pass through the focus. So this is the first incident ray and this is the first reflected ray. How the second ray will pass? Second ray will pass through the focus and it will, so if you will join the, image will come at the C. It means object is at C, image is also at C. Object distance is same, image distance is same, size of the object is same, image height is same as the size of the object. Image height, object height are equal. So what is the NPS? What should I write about NPS? Anyone? Nature. It is below the principal axis? Yes. Real and inverted. Second, position at C, size, same size. same size. I hope everybody is clear. Any doubt till here? Now let's go to the fourth ray diagram. Now first infinity, second beyond C, third ray diagram object at C. It means fourth position is between C and F. In the meantime, guys, please draw the skeleton diagram. I am erasing this. Right? Chalo, shall we start? Hope everybody is ready with their skeleton diagram. This is C, this is F, this is the object. This is the object A, B, right? So first line go parallel to the principal axis. Then how will it refract, guys? It will pass through the focus. And how the second ray will go? Second ray can go through the focus and it will, if any ray pass through the focus, how it reflect? Yes, it becomes parallel to the principal axis. So this is your image. Again, your image is below the principal axis. So it is real and inverted. Second, you can compare the object. It is enlarged. And there it is forming beyond C. There it is forming beyond C. So now can you write yourself characteristic of image? Guys, can you write yourself? Tell me, what is the nature? Real and inverted. Yes. Position beyond C and size enlarged. Right? I think very first four ray diagrams are very much clear. Let's come to the fifth ray diagram. After C and F, what is the position? At focus. What is the position at focus? So please draw the skeleton. This is C. This is C. This is F. Your object is at focus. Parallel, it will reflect through the focus, right? And how the second ray will go? Already object is at focus, tip of the object and C. So if you have a scale, you will draw like this. Guys, if you will draw with the scale now, so it will exactly come like this. Means if you will extend behind also now, they will not meet. Even they are not meeting here, they are not meeting here. Just 1 second. So rays will not meet. Rays will not meet. Can you see here? Rays will not meet. So if the object at F, image is forming at, what is the position? NPS. Object is at infinity. Image is real and inverted. Real and inverted. Position, what is the position? Infinity. And the size enlarged. So if you see the first 5 ray diagrams till focus, all images are real and inverted. Before C, they are smaller. At C, they are same size. After C, image is getting enlarged. So what we are understanding? We are understanding as the object is moving towards the mirror, image is getting enlarged. Shall we do the 6th ray diagram? Yes. 6th ray diagram is very, very important. They relate the ray diagram with the numerical also. They will give you the incident ray. You have to complete the ray diagrams, or they can give you the position, or they can give you the 4 options. You have to choose the correct ray diagram. They can ask in any way. Chalo. What is the position of the object in the sixth ray diagram? Object is very close to the mirror. Object is very near, close to mirror. Very close to mirror means it is between P and F, or we can say object is between F and P. F and P means object distance is lesser than the focal length. Shall we draw? See here. This diagram is something different. So I will draw with a white color. This is CFP. Everybody knows this is a P, right? Object is between F and P. This is A and B. It will go parallel to the principal axis. How will it reflect? First ray will go pass through the focus. I hope everybody is clear till here. First ray will reflect through the focus. How the second ray go? Tip of the object and C. See here, right? Extend it. They are meeting behind the mirror. So image is forming above the principal axis. If you extend the principal axis, image is forming above the principal axis. Am I clear? So when the image is above the principal axis, what is that image called? Virtual and erect. Virtual and erect. The image which cannot be obtained on the screen. So what are the characteristics of image? NPS, virtual and erect position behind the mirror, size highly enlarged. Clear? So these were the 6 ray diagrams of concave mirror, right? So always remember one thing. When you have to draw the concave mirror, read the word. They are saying concave mirror or converging mirror. Remember the measurements. See where they have given you the position of the object. Now, in the next page, I want to tell you one trick. If you see object position, right? It is very easy to remember. So what was the position? At F. Second, what was it? Beyond C. What was the third? At C. What was the fourth? Between C and F. What was the fifth? At F. And what was the sixth? Object between P and F. Right? Now, I am telling you where the image will form. Image position. See, it is very easy. See here. This is the mirror. This is the principal axis. This is the C. This is the F. This is the P. See, one thing remember. This is the first position, infinity. So we can't mark it. So we will mark infinity position. Right? Second position of the object is this, beyond C. Third position of the object is at C, right? Fourth position of the object between C and F. Fifth position of the object is at F. And the sixth position of the object is between F and P. Got it? Now, if the position of object is in infinity first, where does the image form? Listen carefully. At focus. This is the image for the first object. If the object at infinity, image is at focus. If the object is beyond C, where the image will form? Between C and F. Between C and F. And if the object at C, image will also form at C. Image at C. Right? If the object is between C and F, where the image will go? Beyond C. Beyond C. If the object at focus, image will go at infinity. Yellow is representing image. Image at infinity. Whose image at infinity? Object. This is the object position at focus. And if the object at between F and P, where the image go? Behind the mirror. Behind the mirror. I hope everybody understood. Very easy to remember. At focus, image is at infinity. Right? And if the object at focus, so here I'm sorry, I should write object at infinity, then image is at focus. Or if the object at focus, image is at infinity. Beyond C, object is between C and F. Or if object is between C and F, image is beyond C. Image is beyond C. Vice versa. If object at C, image is at C. Image is also at C, between P and F, behind the mirror. Behind the mirror. Got it? Have you guys understood? Great. Now we will learn the ray diagrams of convex mirror. Pause. So now we are going to learn the ray diagrams of convex mirror, which is also called a diverging mirror. Do you remember why convex mirror is called diverging mirror? I told you very clearly, this is a principal axis, rays come, strike the mirror. Instead of meeting, they go away from each other. So that's why it is called a diverging mirror. So rays do not meet actually, they appear to meet. That's why it has a virtual focus. It has a virtual focus. Right? Am I clear, guys? Hope everybody understood. Sure. Now let's do the ray diagrams of convex mirror. It is a diverging mirror. It is a diverging mirror, and it has only two ray diagrams. One, the object is at infinity. First ray diagram, when the object is at infinity, this is object is at infinity. And second ray diagram, when the object is lying on the principal axis at a certain distance. Finite distance means some fixed distance from the mirror. Object is on principal axis at finite distance, but there is no positions like that ki between C and F, nothing. So if they ask you first diagram, draw the ray diagram of the convex mirror when the object is at infinity. Again guys, I am telling you how to do. Take a scale similarly like this. Now draw the one principal axis. Hope everybody understood. Then take a protractor. Now we have to keep the protractor in a C shape. We have to keep the protractor in the C shape like this. How will we keep? I told you we have to keep 90 degree. We have to keep 90 degree, right, like this. Right? My 90 degree is coinciding with the principal axis. 60 to 60, draw the mirror guys. Please draw the mirror 60 to 60. Right? Okay. So your mirror is ready, coat it, because you know bulging surface is the reflecting surface, right? I will extend this principal axis little bit more. I have a less space here. Okay. Now again take a scale, keep 0 at the pole, at 3 and 6, F and C, right? Object is lying on the principal axis AB. Object is lying on the principal axis AB. Okay, this is the, I am doing the, okay, first let me do the first ray diagram when the object is at infinity. So how will you draw object at infinity? First draw the lines coming to parallel to the principal axis. Two lines, one up, one down, coming parallel to principal axis from an infinite. How will they diverge? I tell you. First draw dotted line through the focus if you want to get the perfect ray diagram. Right? Now which is dotted line? Extend that line, diverging line, to get the perfect ray diagram. So what happens sometimes, we draw the diverging line, while extending you bend it. We don't need to bend it, it should be a straight line like this. Got it? Have you understood? So what is the NPS of this ray diagram? What is the NPS? Nature, position and size. Nature, virtual and erect. Virtual and erect. Image, where the image is forming? At focus, behind the mirror. Behind the mirror, and the size is point sized, very small, diminished, point sized. Got it, guys? Am I clear? Let's do the second ray diagram. How we do the second ray diagrams? We will erase all the, you will draw fresh skeleton diagram, right? This is focus, this is C. This is the object A, B, right? This is the second ray diagram when the object is lying on the infinite distance on the principal axis. First ray will go parallel. We know that it will diverge, but how will it diverge? I told you, first draw the dotted line through the focus, and in that direction draw the diverging line. How we draw the second line? I tell you, take a scale, bend it, so I will keep from the tip of the object, right? I have to pass it from the tip of the object and see. Can you see? Tip of the object and see. So where the image is forming? Can you see? Image is forming here between P and F. So rays passing through the C, it will not deviate. It will reflect along the same path. So image is here. Can you see? It is above the principal axis. It is above the principal axis, right? And it is between P and F. So what is the characteristics? Between P and F, behind the mirror, diminished, virtual and erect. So what I want to tell you, convex mirror form only one type of image. What is that one type of image? Virtual, erect and diminished. You don't need to worry about convex mirror, which is a diverging mirror. It has only two ray diagrams and it form only one type of image, virtual, erect and diminished image. Now if I give you the three mirrors, plane mirror, concave mirror, convex mirror, how will you identify which is the given mirror? You can't touch, because all these three mirrors form the virtual and erect image. Listen very carefully. This is a plane mirror, right? Then converging mirror, concave mirror, then convex mirror, diverging mirror, convex mirror, diverging mirror. See, it is called the summary. So, plane mirror, how do we draw the plane mirror? This is my plane mirror. This is the concave mirror, deep inside, and here bulging side is the reflecting side, right? But how? Plane mirror form the virtual and erect image. Virtual and erect image. Okay, but what is the characteristic of image? Image is of same size. Image is of same size, right? Then what about the concave mirror? Concave mirror forms real and inverted. Real and inverted are of three types: diminished, same size, and magnified. Do you understand real and inverted? Ulta. If your candle is like this, inverted image means your candle will appear like this. This is called inverted image, right? Here same size image is inverted. Plane mirror, same size image is virtual and erect. So, two diminished, one same size, two magnified. But sixth type of the image is virtual and erect, that is magnified. So in a plane mirror, it is same size. In a concave mirror, it is virtual, erect and magnified. What about convex mirror? Always virtual, erect and diminished. Virtual, erect and diminished. So this is the way. If I will stand in front of plane mirror, I will look myself as the same size. If I will see myself in a concave mirror, I will see my image as a magnified. If I will see myself in a convex mirror, I will find myself a diminished image. Hope you all have understood. In the next part, we will come up with the numerical.